Predicting climate tipping points. What do you think climate change is? Have you heard about the effects of climate change on our planet? What can we do to help combat climate change? Predicting climate tipping points. A crucial task. Climate tipping points are critical thresholds where small, gradual changes can lead to abrupt and irreversible shifts in the Earth's climate system. Understanding and predicting these points is vital for assessing the potential impacts of climate change and developing effective strategies for mitigation and adaptation. Understanding tipping points. In systems theory, a tipping point is the moment when a system reaches a threshold, triggering significant and often irreversible changes. In the context of climate, tipping points are influenced by factors such as greenhouse gas emissions, deforestation, and ocean warming. Once crossed, these thresholds can result in dramatic changes with far-reaching consequences for ecosystems, human societies, and the global economy. Deeper dive into specific tipping points. While multiple tipping points pose significant risks, two are particularly concerning due to their potential global impacts: the dieback of the Amazon rainforest and the collapse of the Atlantic Meridional Overturning Circulation, AMOC. Amazon rainforest dieback. The Amazon rainforest, often referred to as the lungs of the Earth, plays a critical role in regulating the global climate by absorbing carbon dioxide. However, deforestation and rising temperatures are pushing the Amazon toward a tipping point where it could experience large-scale dieback. If this occurs, the rainforest could shift from being a carbon sink to a carbon source, releasing vast amounts of carbon dioxide into the atmosphere and exacerbating global warming. The loss of biodiversity would also be catastrophic, potentially leading to the extinction of countless species and disrupting ecosystems worldwide. Collapse of the AMOC. The AMOC, a major ocean current that includes the Gulf Stream, helps regulate temperatures in the northern hemisphere by transporting warm water from the tropics to the North Atlantic. A collapse of the AMOC would lead to significant cooling in Europe and North America, while potentially causing droughts and extreme weather in other parts of the world. This shift could disrupt global climate patterns, agriculture, and water supplies, with devastating consequences for human societies. Discussion of uncertainty. Predicting when and if these tipping points will be reached is fraught with uncertainty. The Earth's climate system is highly complex, with numerous interacting variables that make precise predictions difficult. Current climate models, while increasingly sophisticated, have limitations in their ability to accurately predict the timing and consequences of tipping points. For instance, feedback mechanisms, where a small change in one part of the system leads to larger changes elsewhere, are challenging to model accurately. This uncertainty underscores the importance of adopting a precautionary approach to climate policy, where action is taken to mitigate potential risks even in the absence of complete certainty. Exploration of mitigation and adaptation strategies. Given the potentially catastrophic consequences of crossing climate tipping points, it is crucial to implement both mitigation and adaptation strategies. Here are specific examples of what can be done. Mitigation strategies. Reforestation and forest protection. Protecting existing forests and reforesting degraded lands can help absorb carbon dioxide, reduce deforestation, and maintain biodiversity. The creation of protected areas and the enforcement of anti-deforestation laws are vital. Carbon capture and storage. CCS developing and deploying technologies that capture and store carbon dioxide from industrial processes can significantly reduce greenhouse gas emissions. CCS can be applied to power plants, industrial facilities, and even directly from the atmosphere. Renewable energy expansion. Transitioning to renewable energy sources like solar, wind, and hydropower is essential to reduce reliance on fossil fuels. Investments in renewable energy infrastructure and the adoption of policies that incentivize clean energy are crucial steps. Adaptation strategies. Climate-resilient agriculture. Developing and promoting agricultural practices that are resilient to changing climate conditions can help ensure food security. This includes breeding crop varieties that are drought-resistant and implementing water-efficient irrigation systems. Infrastructure upgrades. Building or retrofitting infrastructure to withstand extreme weather events, such as floods and hurricanes, is necessary to protect communities. This includes improving drainage systems, constructing seawalls, and designing buildings to withstand high winds. Community-based adaptation. Engaging local communities in the development and implementation of adaptation strategies ensures that solutions are tailored to specific local conditions and needs. This can include early warning systems for extreme weather, sustainable land management practices, and disaster preparedness training. Predicting and preventing climate tipping points is a critical task that requires ongoing research, international cooperation, and proactive policymaking. While uncertainty remains, the potential risks are too great to ignore. By implementing targeted mitigation and adaptation strategies, we can reduce the likelihood of crossing these dangerous thresholds and protect our planet. As individuals, we can contribute by advocating for sustainable policies, reducing our carbon footprints, and supporting initiatives that promote environmental resilience. Together, we can work to ensure a sustainable and resilient future for ourselves and future generations. youtube.com/RuiEnglish